Hi guys. All right, so today we will see redox reactions and we'll see how to write down half equations and use those to balance overall equations. So let's see, redox comes from the word reduction and oxidation. What is reduction? Where there's a decrease in oxidation number. And what is oxidation? Oxidation is when there's an increase in oxidation number. In reduction, there is gain of electrons, and oxidation is the loss of electrons. Now, normally for a overall equation, you have two half equations which you pick from the data booklet and you balance them, ensuring electrons on both sides are equal, and you can write the overall and balance the overall. But if the half equations are not given, if you've just been given the overall equation, how do you derive the half equations? Let's see. So let's see the steps in writing half equations. So let's see the first step. The first step in writing half equations is to calculate the oxidation states on each side of the equation. So you calculate the oxidation state on the reactant side as well as on the product side. I'm using this as an example. So you have VO2 plus becoming VO2 plus, right? So let's see how we calculate the oxidation state of vanadium. So let's calculate the oxidation state on both sides. So this will be X plus, oxygen is -2. So you have -2 and the whole thing has a charge of 2 plus. So the whole thing will be equals to +2. So this becomes X is equals to +2, X becomes +4. So vanadium here is +4. Let's see vanadium's charge oxidation state here. So it will be X plus. Now you have two oxygens. Each oxygen is a -2. So you will do 2 times -2. And the whole thing is equals to +1. You calculate this, it will be X is equals to +1, +4, and X comes out to be +5. So the first thing you do is you calculate the oxidation states on both sides and figure out whether it is oxidation or reduction. You can see oxidation number is increasing. Therefore, this would be what? Oxidation. Yes, as you can see, it goes from +4 to +5. So it must be oxidation, which is the loss of electrons. Yeah. Once this is done, you move on to step 2. What is step 2? In step 2, you balance the element, changing the oxidation state. So you balance the element that is changing the oxidation state. So in this example that I've taken, they're already balanced. You have one vanadium here, one here. So you don't really need to balance, it's already balanced, right? So you balance the element that is changing the oxidation state, which in our example, they are already balanced because you have one on each side. Step number 3, what do? You sort out electrons. So in step 3, we sort out electrons. We know that it is undergoing what? Oxidation. So oxidation means what? Loss of electrons. So this will be losing electrons, yes? So you will say BO2 plus is losing electrons to become this. And how many electrons would it have lost? You see, it goes from +4 to +5. So it's increasing by 1. That means it must have lost 1 electron. So you will make it lose 1 electron. And this is what we will get. Yeah. So you see the state was changing from +4 to +5. That showed that it is undergoing oxidation. Oxidation is a loss of electrons. It is changing by 1. Therefore, this must be losing 1 electron. Clear? Then you sort out the O's in the next step. Once the electrons are sorted, you sort out the oxygens, right? How do we sort out oxygen? For every oxygen gained or lost, you add or remove 1 water molecule. So for every oxygen gained or lost, we add or remove. So you add or remove one H2O molecule. Let's see. For example, here in our equation, we had VO2 plus becoming VO2 plus plus electron. Now, if you see the oxygens, here we have two, here we have one. So here you have two oxygen, you need to balance them out now. So in order to balance them out, you will add or remove a water molecule. So since you have two oxygens here, to make it two on this side, we will add H2O over here. Do you see this side also has two oxygens now, and so does this? Once this is done, in your next step, you will sort out the hydrogens. So in step number 5, you sort out the hydrogens. For every H gained or lost, you add or remove one H plus ion. So you add or remove one H plus ion. Let's see using the same example. So you have H2O plus VO2 plus becoming VO2 plus plus electron. Now, if you see, oxygens are balanced, our charges were balanced, but you have two hydrogens here and you have none on this side. So what will we do? We will add two H pluses over here. Yeah, because to sort out hydrogens, you got to add or remove H plus. So this has two hydrogens. So to make it two on this side, we will add two H pluses. And the last thing you do is you check that the charges on the right are equal to the charges on the left. So you check that charge on the right-hand side is equal to the left-hand side. Let's see how we do that. So if you see the charge on the right-hand side, this has an overall charge of 0. This is 2 plus. So charge on this side is plus 2. Charge on this side is plus 1, plus minus 1, plus each hydrogen is plus 1. You have 2, so that will be plus 2. This and this cancels out, and the overall charge on this side is also plus 2. You see the charges on both sides is plus 2. So this right here is a balanced equation. Now, before I move on to solving questions on redox, I will just write down some half equations, just help you figure out how to write down half equations using these steps. So let's see. Let's see an example. For example, if we were to write down a half equation where Cr2O7 2 minus is becoming Cr3 plus. So imagine we need to write down a half equation for this change. So you see chromium is becoming from God knows what to 3 plus. So first thing we got to find is the oxidation state of chromium here. How will we do that? You have two Crs. So that will be 2x plus 7 oxygens. Each oxygen has a charge of minus 2. So 7 times minus 2, and the whole thing is equals to minus 2. You find the value of x. X comes out to be plus 6. So you know this is plus 6 and it's going to plus 3. So we know that this is undergoing what? This is undergoing reduction. As you can see, there's a decrease in oxidation number. So this is what? Reduction. Yeah. Now, reduction is what? The gain of electrons. So first thing what we will do is, we will write down our equation by finding the charges. Now, the first thing we'll do is, we've calculated the oxidation states on each side. Now we will balance the element that is changing the oxidation state. Yeah. So we have this becoming Cr3 plus. Now you have two Crs here. So you will put a 2 here. The first thing we do is balance them, right? Then we sort out the electrons. Now we know this is going from plus 6 to plus 3. So this is going from plus 6 to plus 3. So there's a decrease by 3. So reduction we know is what? Gain of electrons. So this must be gaining electrons. How many? 3 electrons in order to make 3 plus. Because from plus 6 to plus 3, there's a change of 3. So this must be reducing by 3. That means it must be gaining 3 electrons. Yeah. So each CR gains 3 electrons. How many do we have here? 2. So they must be gaining how much? 6 electrons. Clear? So we've balanced the electrons. So we know that since one of them would be gaining 3 electrons to make 6 plus become 3 plus, so 2 of them would be gaining 6 electrons. We've balanced them. Now we balance the O's. You have 7 oxygens over here. And for each oxygen, you add or remove a molecule of water. So you have 7 O's here. You need 7 O's over here. So you add 7 H2O. Oxygens are balanced. Now you need to balance the hydrogens. You have 14 H pluses over here. You have none on this side, no hydrogens on this side. So you will add what? 14 H plus on this side. And this becomes your half equation. Let's see another example. Let's see IO3 minus becoming I2. Let's see the half equation for this one. First thing, we will find the oxidation state of iodine here, and we know this is already 0. So find this will be x plus 3 times minus 2 is equals to minus 1. And you find this comes out to be what? Plus 5. So this is plus 5, and it's becoming what? 0. So this is what? Reduction. And we know reduction is what? Gain of electrons. And how many electrons do you think it must have gained? It must have gained 5 electrons because it's going from plus 5 to 0. Yes? So this is change of 5. Let's see. First thing, you balance the element that is changing the oxidation number. You have 2 iodine here, so you put a 2 here. Now this is undergoing reduction, we know. Reduction is what? It is the gain of electrons. And we know it's going from plus 5 to 0. That means it must be gaining 5 electrons. So each I gains 5 electrons. How many do we have? 2. So that must be gaining 10 electrons. Then we balance the oxygens. You have 2 3s are 6 oxygens on this side. So you need 6 on this side. So you will add 6 moles of water over here. Once this is done, you got to balance the H. You have 12 H's over here. You have none on this side. So you will add what? 12 H plus. And this right here is balanced. And you can also check. You can check here the charges 2 minus, and then you have 10, and then you have 10 minus, and you have 12 H pluses, right? And over here, so you have minus 2 plus minus 10 plus 12. So this is what? This cancels out. And over here, also the charge is 0. Yeah? So minus 12 and plus 12, they cancel out, become 0. And the charge over here is also 0 because this is 0 and this is 0. So we know this is a balanced equation. Now let's see questions on redox. So let's see this. The first stage in the manufacture of nitric acid is the oxidation of ammonia by oxygen. They've given you the overall equation, right? And they're asking you to balance this equation, and you need to give values of W, X, Y, and Z. Now let's see what's happening to nitrogen. Here, it's going from ammonia to NO. So let's find the oxidation state of nitrogen in here and here. Yeah. So you're going from ammonia to NO. Let's find this oxidation number of nitrogen for both. So this right here would be X plus 3 times hydrogen is plus 1. The whole thing is equals to 0. X comes out to be minus 3. Here, nitrogen is X plus oxygen is minus 2. The whole thing has a charge of 0. So X comes out to be plus 2. So this right here is plus 2. So it goes from minus 3 to plus 2. And you can see what is this? This is oxidation because there's an increase in oxidation number, right? So first thing we will do, we know ammonia is becoming NO. And this is oxidation. Oxidation is what? It is the loss of electrons. Yeah. So this must be losing electrons. Now, how many electrons you think it must have lost? First thing we had to do was balance these elements that are changing the oxidation number, but we don't have to for this specific example because the nitrogens are already balanced. Yeah. Now this is going from -3 to +2. So it is changing by a factor of, it's going from -3 to -2, -1, 0, +1, +2. So it's changing by 5. So that means it must be losing 5 electrons. Once this is done, you balance the oxygens. Electrons are balanced. Now you balance the oxygens. You have 1 oxygen here, none here. So you add an H2O. Then we balance the hydrogens. You have 3, 5 hydrogens over here. So we will add 5H plus over here because there were none on this side. You've got 1/2 equation. Let's see the second. Oxygen from 0, because in elemental form, the oxidation number is 0. So it goes from 0 to, let's say, H2O. So let's see how it's changing. So it's going from oxygen to H2O. So oxygen goes from 0 to here, it would be 2 times +1 plus X. X comes out to be -2. So oxygen goes from 0 to -2. So this is what? Reduction. Yes. So this right here is reduction, which we know is what? It is the gain of electrons. So let's see. First thing, O2 becoming H2O. First thing we got to do is balance the element that is changing the oxidation number. You have 2 over here, 1 on this side. So we put a 2 here. Each oxygen is changing by a factor of 2. You see, it goes from 0 to -1, -1 to -2. So it's changing by 2. Yeah, it's changing by 2. And this is gain of electrons because it's undergoing reduction. So each oxygen is gaining 2 electrons. So 2 oxygens would be gaining 4 electrons. So you make it gain 4 electrons. Once this is done, you balance the oxygens, which are already balanced. Then you balance the hydrogens. We balance the hydrogens. We have 2 2s are 4 on this side, none on this side. So we add what here? 4H plus. Now we have 2/2 equations. This is the first, this is the second. Now let me just put them down together. Let me write the other one here, NH3 plus H2O giving NO plus 5 electron plus 5H plus. You see, one is gaining electrons, one is losing. This is redox. And how do we add them now? We add them ensuring electrons on both sides are equal. This is losing 5, this is gaining 4. So the exchange needs to be equal. So you multiply this whole thing by 5, multiply this whole thing by 4. When you do that, electrons on both sides become equal, they cancel out. Let's see the overall now. This becomes 5 4s are 20H plus. Then you have 5 oxygens with 4 moles of ammonia because you multiply this 4 by ammonia. So write all the reactants on the reactant side. Then 4H2O. Then we have 2 5s are 10 H2O on the product side here. And we have 4 NO. And we have 4 5s are 20 H pluses. Now you see the H pluses also cancel out. Then what else cancels out? Water. You have 10 on this side, 4 on this side. So this becomes 6H2O. So you have 6H2O, 4NO, and we are left with 5O2 plus 4NH3. So this is your overall balanced equation. Now they're asking you to fill in the values for, I guess, W, X, Y, Z, yeah, where W is basically the coefficient for ammonia. So we know that is 4. X is the coefficient for oxygen, which is 5. Y is NO, that is 4. And Z is H2O, that is 6. The answer, therefore, is 4 5 4 6, that is A. Yeah? Is this clear? All right. So let's see another example now. In aqueous solution, the acid HIO disproportionates. We know what disproportionation is. where the same element undergoes both oxidation and reduction. So let's see. According to the following equation, where M and PQ are simple whole numbers in the lowest ratios. So let's see. You have HIO becoming iodine and HiO3. So the first thing we got to do is we got to calculate the oxidation numbers. So let's calculate the oxidation number of iodine in HIO. So this would be +1 plus X plus -2 is equals to 0. So this becomes X is equals to +1. Then we have HiO3. For HiO3, again, got to calculate the oxidation number. So this comes out to be +1 plus X plus 3 times -2 is equals to 0. X comes out to be +5. Now, this goes from +1 to 0, which is reduction. And it goes from +1 to +5, which is oxidation. Now let's write the half equations. So the first one is HiO becoming iodine. Yeah. And this is reduction. Yeah, because it goes from +1 to 0. Reduction is what? The gain of electrons. First thing you got to balance is the elements that are undergoing the change. You have 2 iodines over here. You put a 2 over here. Now the change is by how much? From +1 to 0. So only changing by 1. Yeah, from +1 to 0. So each iodine must be gaining 1 electron. Since you have 2 i's, they'll be gaining 2 electrons. Yeah, to make I2. Then we balance the O's. You have 2 O's on this side. So you put 2 H2O over here. Now you have 4 H's on this side, 2 on this side. So you put 2 H plus over here. Done. Let's pick the next equation. So HiO becoming HiO3. Now this right here goes from +1 to +5. So this is what? Oxidation, which is the loss of electrons. And how many electrons would it be losing? So it's going, so they're already balanced. 1 I, 1 I. So you don't need to balance them. Let's balance the electrons. So it's changing from +1 to +5. So it's changing by how much? By 4. So this must be losing 4 electrons. Yeah. And why losing? Because oxidation is the loss of electrons. So it goes from +1 to +2 to +3, +4, +5. Clear? So 4 electrons are lost. Then you balance the oxygens. You have 3 over here, 1 over here. So you add 2 H2O over here. Now oxygens are balanced. Now you got to balance the hydrogens. You have 1 and 4, 5 hydrogens on this side. You have 1 on this side. So you add what? 4H plus over here to balance the hydrogens. Clear? Once this is done, you have the 2 half equations. You add the 2, ensuring electrons on both sides are equal. Electron transfer must be equal. This is losing 4, this is gaining 2. So you multiply this whole thing by 2. And this will become what? Now you add all the reactants, put them on the reactant side. So this will become 4HIO. 4 with this one will become 5HIO. Plus electrons cancel out. Yeah. Then this will become 2 2s are 4H plus. Then you will have, I've already accounted for this here. Yeah. Then you have 2H2O becoming 2I2 plus 4H2O plus 4H plus HiO3. So I added all the products, put them on the product side. Yeah, multiplying these 2 by 2. Now, the 4H pluses cancel out. The water cancels out. You will have 2H2O left here. Yes. So now we have our overall equation. It is 5HIO giving you 2I2 plus 2H2O plus HiO3. This is the overall equation. Now let's see. Let's put it here. we got to give values for N and P. N corresponds to iodine, which is 2, and P corresponds to HiO3, that is how many moles? 1. So P is 1, N is 2. The answer is B. I hope this is clear. Take care.